Welcome students. Today we are going to discuss about molecular mass and gram molecular mass. First of all, we want to calculate the molecular mass of hydrogen, oxygen, nitrogen, water and ammonia. Then how can you calculate that? So here H2, we are representing hydrogen as H2. So here how many hydrogen atoms? 2 hydrogen atoms. So it is simply 2 into atomic mass of hydrogen. Atomic mass of hydrogen is 1. So 2 into 1, that is equal to 2. So 2 is the molecular mass of hydrogen molecule. Then oxygen is represented as O2. Then we want to find the molecular mass. Check how many oxygen atoms? 2 oxygen atoms. So 2 into atomic mass of oxygen 16. 2 into 16 is equal to 32. Okay, this is the way. Then nitrogen, N2, we are writing as N2. So how many nitrogen atoms are there? 2 nitrogen atoms. So 2 into atomic mass of nitrogen 14. So 2 into 14, that is equal to 28. This is the way we are finding the molecular mass of these molecules. Then another way is there, 2 hydrogen atom, mass of hydrogen, atomic mass of hydrogen is 1. So we can simply write what? 1 plus 1. So that is equal to 2. Then in here O2 is there, 2 oxygen atom, mass of oxygen 16. So 16 plus 16, 32. That is the way we are writing like this. Then N2, 2 nitrogen atom. So 14 plus 14, that is 2 into 14, 28, same. So this is the way we can find the molecular mass of the substances. Here water H2O, how can you find the molecular mass? 2 hydrogen atom. So 2 into mass of hydrogen 1. So 2 into 1. So next atom is there plus oxygen. How many oxygen atoms are there? 1. So 1 into mass of oxygen, atomic mass of oxygen is 16. 2 into 1 is equal to 2. Then 16 into 1 is equal to 16. 2 plus 16, 18. 2 plus 16, 18 is the way to find the molecular mass. One more method is there, 2 hydrogen atoms. So can you write 1 plus 1, 2 hydrogen atom, 2 hydrogen atom, 1 plus 1 plus 1 oxygen atom. So mass 16, 1 plus 1, 2, 2 plus 16, 18. Same way we are finding the molecular mass. Next one, NH3, that is ammonia. So we can find that 1 into 1 nitrogen atom, 1 into 14 plus 3 hydrogen atoms, 3 into 1. 1 into 14 is equal to 14. 3 into 1 is equal to 3. So 14 plus 3 is equal to 70. Okay, one more method. The another method is there to find the molecular mass as 17. Nitrogen, 1 nitrogen atom. So 14 plus 3 hydrogen atom. 1 plus 1 plus 1. So same, 70. This is the way to find the molecular mass. So students, it is easy to find the molecular mass of a substance. So here is a question for you to find the molecular mass, of the following substances. These are the question for you. First one, it is C6, H12O6 is glucose. Then H2SO4 sulfuric acid. Then third one, calcium carbonate CaCO3. The next one is sodium chloride. This is the question for you. Find the molecular mass of these substances: glucose, sulfuric acid, calcium carbonate and NaCl. We are write the atomic mass, corresponding atomic mass in your notebooks. By checking that, you just find the molecular mass of these compounds. Okay, this is for your homework question. All of you want to write this 1, 2, 3, 4. Next one, next topic or next section we are going to discuss, it is gram molecular mass. Gram molecular mass. Gram molecular mass is represented as GMM. Gram molecular mass. The amount of substance is numerically equal to the molecular mass of that substance is known as gram molecular mass. If you take a substance in gram that is numerically equal to the molecular mass of that substance is known as gram molecular mass. Example, 1 gram molecular mass, 1 GMM, 1 gram molecular mass N2, that is nitrogen, 1 gram molecular mass nitrogen. So that is equal to, it is simple to write the method You just express the molecular mass of nitrogen in gram. Express the molecular mass of nitrogen in gram. You already find that the molecular mass of nitrogen is 28. That is expressed in gram. We can get 28 gram. So 1 GMM nitrogen is equal to 28 gram. Then 1 gram molecular mass, 1 gram molecular mass water, H2O. 1 gram molecular mass H2O. What do you want to write there? Water is taken, its mass amount is numerically equal to the molecular mass. So simple. Express the molecular mass of water in gram. Express the molecular mass of water in gram. So what is the molecular mass of water? It is 18. So that is expressed in gram, 18 gram. That is equal to 1 gram molecular mass water. So one more question. If it is 2 gram molecular mass, 2 GMM NH3, 2 gram molecular mass ammonia, what you want to understand? Express the molecular mass of ammonia in gram. How many times? 2 times. Express the molecular mass of ammonia in gram 2 times. So how you write it? 2 into molecular mass of ammonia, 14 plus 3, 17. So 2 into 17 is equal to 34 gram. So this is the thing related with the gram molecular mass. Gram molecular mass. Okay, 1 gram molecular mass, that implies the amount of substance that is numerically equal to the molecular mass of that substance. Or you just simply express the molecular mass of a substance in gram is known as 1 gram molecular mass. Another important thing is that if you take 1 gram molecular mass of any substance, if you take 1 gram molecular mass of any substance that contain 6.022 into 10 raised to 23 molecules. If you take 1 gram molecular mass of any substance, whether it is ammonia, carbon dioxide, oxygen, hydrogen, water or anything. If you take 1 gram molecular mass, that is equal to the molecular mass of substance that contains 6.022 into 10 raised to 23 molecules, 1 gram molecules. Then 2 gram molecular mass, 2 GMM contain 2 into Avogadro number of molecules. That means 1 gram molecular mass contain Avogadro number of molecules. So 2 GMM contain 2 into Avogadro number of molecules. If it is 5 gram molecular mass, 5 GMM of any substance that contain how many molecules? Yes, that contain 5 into 6.022 into 10 raised to 23 molecules. That contain 5 into 6.022 into 10 raised to 23 molecules are there. Then one question related with that, 1 GMM carbon dioxide CO2, 1 GMM carbon dioxide is equal to 1 gram molecular mass. 1 GMM carbon dioxide is equal to 44 gram. If you find the molecular mass, you get 44, that is 44 gram. The question is that if you take 220 gram carbon dioxide, if you take 220 gram carbon dioxide, if you take 220 gram carbon dioxide, calculate the number of GMM. If you take 220 gram carbon dioxide, calculate the number of GMM. So we have 220 gram. 1 GMM is equal to 44. Then 220 gram. If you take 220 gram, how many GMM is there? So that is easy. How can you calculate the number of GMM? Number of GMM is equal to number of gram molecular mass is equal to given mass divided by gram molecular mass of that substance. Number of GMM is equal to given mass divided by GMM. Students, it is important. You want to note in your notebook. Number of GMM is equal to given mass divided by GMM. Number of GMM is equal to given mass divided by GMM, gram molecular mass. So here you want to find that. 220 gram CO2, you want to find the GMM. So 220, given mass is equal to 220 gram divided by GMM of carbon dioxide, that is 44. 220 divided by 44 gram, the gram and gram is cancelled. Then 220 divided by 44, if you calculate that, you get 5. 5 is the answer. So here it is 5 GMM. So 220 gram carbon dioxide is equal to 5 GMM. Then you have one more question. That is, if you take 320 gram oxygen. If you take 320 gram oxygen, the question is that find number of GMM. Find the number of GMM. So you know that number of GMM is equal to given mass divided by gram molecular mass. Given mass divided by gram molecular mass. So here given mass is equal to 320 gram divided by gram molecular mass of which one? Oxygen. Gram molecular mass of oxygen is equal to 32 gram. So gram and gram cancelled. 320 divided by 32, you get the answer 10 GMM. 10 gram molecular mass. Then one more question is include that if 320 gram oxygen find the number of GMM, and also one more question, if they ask calculate number of molecules. Calculate the number of molecules. You know that 1 GMM contain how many molecules? 1 GMM contain 6.022 into 10 raised to 23 molecules. 1 GMM contain 6.022 into 10 raised to 23 molecules. Here how many GMM? 10 GMM. So number of molecules is equal to 10 into 6.022 into 10 raised to 23. Number of molecules is equal to 10 into 6.022 into 10 raised to 23 molecules are there, because 1 GMM contain Avogadro number of molecules. 10 GMM contain 10 into 6.022 into 10 raised to 23 molecules. So this is the calculation. Then we are going to discuss second topic related with that, moles of molecules. What is moles of molecule? 1 mole, that means 6.022 into 10 raised to 23 particles. If a substance that contains 6.022 into 10 raised to 23 particles, that is known as 1 mole. If it is 6.022 into 10 raised to 23 molecules, that is 1 mole. So what do you want to understand? 1 mole water, 1 mole H2O, that is equal to what? 1 gram molecular mass of what? 1 gram molecular mass of H2O. 1 mole H2O, that means that contain Avogadro number of particles, that is equal to 1 GMM of water. So 1 mole H2O is equal to 18 gram. And the same, if it is 1 mole, another question, 1 mole NH3 is equal to 1 mole NH3. So the molecular mass expressed in gram is the 1 gram molecular mass, that is equal to what? 1 mole. So 1 mole Avogadro number of particles are there. So the Avogadro number of particles equals 1 mole. So 1 mole NH3 is equal to what? Its molecular mass 17 gram. So one more question, 5 mole NH3 is equal to 5 mole NH3 is equal to 1 mole NH3 equal to 17 gram. Then how many molecules are there? 6.022 into 10 raised to 23 molecules. Then 5 mole NH3 is equal to 5 into 17. 5 into 17 is equal to 85 gram. 5 into 17 is equal to 85 gram. Then how many molecules are there? 5 into 6.022 into 10 raised to 23 molecules. Okay, molecules. So this is the calculation. So 1 mole contain how many molecules? 1 mole contain Avogadro number of molecules. So then 5 mole contain 5 into Avogadro number of molecules. 5 into Avogadro number of molecules are there in the substance. Okay, this is the concept. It is very easy to find. So we have to do one question. Okay, the question is that if you take if you take how many gram? 400 gram calcium carbonate. If you take 400 gram calcium carbonate, then find the molecules. If you take 400 gram calcium carbonate, find number of molecules. Okay, find number of molecules. That is a question. If you take 400 gram calcium carbonate, calculate the number of molecules or find the number of molecules. So we want to find the number of molecules. We want to calculate the number of moles. So we want to calculate the number of moles. Number of moles is equal to 400 given mass divided by molecular mass of calcium carbonate. Molecular mass of calcium carbonate, if you find that, it is get 100. Okay, so 400 divided by 100 gram, that is equal to 4 mole. 400 divided by 100, it is gives 4 mole. 1 mole contain how many molecules? 1 mole contain Avogadro number of molecules. So 4 mole contain 4 into 6.022 into 10 raised to 23 molecules. Because 1 mole contain 6.022 into 10 raised to 23 molecules. So 4 mole contain 4 into 6.022 into 10 raised to 23 molecules. This is the calculation related with the number of moles. One number of moles. So that is important thing is that if it is case, if you contain related with mole, if it is atom, number of moles of atom, that is equal to 1 GAM, 1 gram atomic mass. If in the case of molecules, that is 1 mole molecule. 1 mole molecule is equal to 1 GMM. 1 mole molecule is equal to 1 GMM. If the 1 mole particle or 1 mole atoms or molecules, number of 1 mole particle that contain, if it is 1 mole atom, 1 GAM. 1 mole molecule, it is 1 GMM. Then 1 mole particles is equal to 6.022 into 10 raised to 23. Okay, 6.022 into 10 raised to 23. So these are the important concept we are discussed in this area. So students, all of you practice the problems well. Then next topic we are going to discuss about, it is related with volume and moles. Volume and mole. So we are discussing related with the volume and mole. The volume is especially related with is only for what? Gases. In the case of gases, the molecules are far apart. That's why the number of molecule is less important. Their volume is less, their size is less important. The number of particles and volume are relating. Their size is less important. Their number and the volume we are discussing. Here the important is that the volume of 1 mole gas, volume of 1 mole gas is known as what? Molar volume. Volume of 1 mole gas is known as molar volume. Volume of 1 mole gas is known as molar volume. At STP, that's another section, STP. STP is the standard temperature and pressure. STP is standard temperature and pressure. STP, standard temperature and pressure. The temperature is 273 Kelvin. If you take the temperature as a constant or standard value, 273 Kelvin, and pressure is taken as 1 atmospheric pressure, 1 atm. So STP standard temperature and pressure. So the temperature is 273 Kelvin and 1 atm atmospheric pressure, that is the pressure, that is STP. These are the value STP, standard temperature and pressure. So the constant temperature and pressure, if you take 1 mole of gas, its volume is always 22.4 liter. It is experimentally calculated value. 22.4 liter is the volume of a gas. 1 mole of gas is taken at 273 Kelvin and 1 atm. So that is known as molar volume. That is known as molar volume at
STP. That is known as molar volume at STP. That is equal to what? 22.4 liter. 22.4 liter. So what do you want to understand from this value? What do you want to understand from this value? So at STP, 1 mole oxygen. At STP, 1 mole oxygen is equal to 22.4 liter. At STP, 1 mole oxygen is equal to 22.4 liter is volume. Okay, at STP, the volume. Then at STP, 1 mole carbon dioxide is equal to 22.4 liter. So if any gas, whether it is oxygen, carbon dioxide, ammonia, methane, butane, or any gas, if it is a gas, if you take 1 mole at STP, its volume is always 22.4 liter. Then if you take 2 mole ammonia. So what is the volume at STP? So 2 into 22.4 is equal to 44.8 liter. So this is the value you want to understand. Then if they ask, if you take 111 liter CH4 at STP, if they ask 111 liter CH4 at STP, how can you calculate the number of moles? That is calculated by the equation volume of gas at STP, divided by 22.4 liter. Volume of gas at STP divided by 22.4 liter. That must be in liter. The volume must be in liter. So what do you get the answer? 112 liter divided by 22.4 liter. Liter cancel. 112 divided by 22.4 is equal to 5 mole. So this is the calculation. Okay, because 1 mole contains 22.4 liter, then they will ask 112 liter is equal to 112 divided by 22.4, so is equal to 5 mole. This is the way to calculate the number of moles. So molar volume of 1 mole gas is known as molar volume. If the volume of 1 mole gas at STP, standard temperature and pressure, is known as molar volume at STP. The molar volume is calculated value, experimentally proved value, it is 22.4. If the temperature or pressure is changed, this value is also changed. Okay, 1 mole carbon dioxide is equal to 22.4, 2 mole NH3 is equal to 2 into 22.4. Like that we are discussed. So 1 mole atom, 1 GAM. 1 mole molecule is 1 GMM. 1 mole particle, it is equal to 6.022 into 10 raised to 23. If it is 1 mole gas at STP, that is equal to 22.4 liter. Up to here, this is our second chapter, so it is completed. All of you practice all the questions given in your textbook and also complete the latest assess given at the last of the chapter. Thank you.